In this video, I'll be explaining question 1 of homework 4. So we are given y equals to g of x as follows, and we need to find the CDF and PDF of y in terms of the CDF of and PDF of x. So first of all, we plot the graph y equals to g of x. So as we see, for x less than 0, y is equal to 2. For x between 0 and 1, y is 0. For x between 1 to 2, y equals to minus x plus 1. So this is a straight line with slope of minus 1 and intercept on x-axis as 1. For x greater than 2, y is equal to minus 1. So since we know that the value of y is between minus 1 and 2, from the graph we can see that y can take only values between minus 1 and 2. We know that for the f of big F of y, for a y less than minus 1 will be 0, and for y greater than 2 will be 1, because the probabilities sum up to 1. So we have written this. Now for we need to find for y between minus 1 and 2. So we'll consider different cases. First, let's see what will happen when y equals to minus 1. So probability y equals to minus 1 can also be written as so when y equals to minus 1, x is greater than 2. So we can write it as probability of x greater than 2, which is 1 minus probability of x less than equal to 2. And this is basically capital F x of 2. Now for y equals to 0, we need to find probability at y equals to 0. This can be written as, so y is 0 when x is between 0 and 1. So this is basically probability of x between 0 and 1, which can be written as f of x 1 minus f 0 of x. And at y equals to 2, so when we see y equals to 2, x is less than 0. So this can be written as fx of 0. Now we'll also consider the case when y is between minus 1 to 0. So we can write it as probability of y is less than equal to y, small y. And we know that in this interval y is given as 1 minus x, minus x plus 1, which is 1 minus x. So on solving this, moving x on one side of inequality, we get probability of x greater than equal to 1 minus y, which can be written as 1 minus probability of x less than equal to 1 minus y. Since the probability sum up to 1, the inequality will change, and this can be written as 1 minus fx of 1 minus y. Now in the interval of y between 0 and 2, we can get the probability as 1 minus fx of 0. Now in order to get small fy, we can differentiate the big fy, and for different values of y we'll get the values as follows. So let's see, for example, for y equals to minus 1, we'll get this as 1 minus fx of 2 times impulse y at y plus 1. Similarly, for y between minus 1 to 0, if we differentiate fy of y, which is 1 minus this term, so we'll get this as fx of 1 minus y. And similarly, we calculate for all the scenarios. and this is the capital F of y, which we got from the above calculations, and we can simply plot these values. So from here we can see that uh, fx of x is plotted as follows, and the capital F of x can be represented using this, which will be the integral of this function. Fy, which is the CDF, can be given as this plot. So here we can see for y less than -1 we have plotted as 0. For y between -1 and 0 we have plotted as 1 minus fx of 1 minus y, and for y between 0 and 2 it is 1 minus fx of 0, which is a constant, so we have drawn the constant line, and for y greater than equal to 2 we have the constant 1 in our plot. And similarly, from these calculated values we have plotted the values over here. So we can see here we have drawn out the impulses at -1, 0 and 2 through the values that we calculated over here, and for interval -1 to 0 we have f of y as fx 1 minus y, which we have drawn as follows, and for the other intervals, for other values of y, we have the function as 0. So this is how we have plotted the graph.